Okay, so we are recording. That's good. And Nick, one of your classmates, has volunteered to be my old guy in the crowd, and he could hear me before, so I'm assuming that you all can hear me. Now, if you have questions, and there are tools for raising hands, and there's tools for chatting, or you can just go off mute and shout out a question, and I'll manage through that somehow. Okay, so thank you all for coming and studying math with me, and we're going to begin pretty much right away. Now, what I need to do first is I am going to be sharing my application screen with you. And so, Nick, in a moment, not necessarily right now, but in a moment, you should be looking at a chart that is, it's like a PowerPoint slide. So, and let's see, there we go, talking points.
Yep, I can see it. You're all good.
Thank you, Nick.
Yeah.
And you're doing exactly what I need someone to do. So these are talking points. Now, what I'm going to do is I'm not sure exactly how far we'll get today or anything like that, and that doesn't matter. I've taught this course many times. It's all going to work out just fine. I'm not sure exactly how this will work out. I will post the talking points. Actually, I will post the video of the talking points in the announcements. Not immediately, but soon. I will do that, and I'll also probably post the talking points as far as we get. So I'm not sure how far that will be, but that's what's going on. Okay, so with that, then I'm going to begin and move to the next slide. Okay, now I have already appointed my VCM deputy today, and this is Nick. And Nick, I'm thinking you can see me wiggling my cursor. Is that true, Nick?
Yeah, I can see that.
Excellent. So I'm going to just assume everybody can see that, so that is all good. Now, I did invite my co-pilot for this course, a young man named Jesse Hayes Carver, who is fully qualified, in fact, to be an instructor at the College of DuPage. He just finished his master's degree in mathematics from Illinois State, and I've actually worked with Jesse Hayes Carver many times. But Jesse sent me a text late last night and said he wasn't going to be able to do a cameo here today, but he would be sharing us information about the guided study groups. I'll say more about this, but just let me say this right here, that Jesse Hayes Carver is the real deal. Okay, when you're talking to him, it's almost as good as you're talking to me. And so he's a significant resource. He is the ace of the staff, and he's working with us this term. We worked together many times, and in fact, we've worked together many times in calculus too. And so Jesse Hayes Carver, our GSG leader, is not going to be stopping in with us this morning, but he's somebody that could be very useful for you to know. And I know I talked a little bit about that. All right, so what are we going to do today? Well, I am going to walk through the syllabus. And I know this is kind of boring, and actually you've heard all of this stuff before, because I've already told you about all this stuff with videos and things like that, but I want to go through and do it. Now, the next thing I want to say is that your questions are always welcome, but I am going to have pause for every so often and just ask, are there questions? Now, you don't have to wait for me to ask if there are questions. You can just jump right in, and that's all good, and I'll answer your questions as best I can. Your questions are important, and I hope that this class can be somewhat interactive, although it's going to be a bit of a challenge making a VCM interactive, although I have some ideas and things like that. Okay, so your questions are always welcome. We are first going to do a detailed syllabus walkthrough, and so that's what we're going to do. Now, I have taught, many times in many different formats, and this fourth bullet point is one of the things that I have learned along the way. It is really difficult for anybody to listen to me for more than 75 minutes. So that means that we're going to take a break more or less at 9:15. Now, it won't be precisely at 9:15, but I do watch the clocks and I know what time it is and things like that. And so on or around 9:15, I'll declare a 10-minute break. And so you can refresh your coffee or, I don't know, get a donut or whatever, but it is 10 minutes and then we'll start again. And we will go for 50 minutes when we return. Now that means we're going to be meeting and having contact for 125 minutes today. Now I am going to show you something, and Nick, I will be asking you if you can see this because I'm going to stop sharing this for now, and I am going to go to Blackboard, and I am going to share a blank whiteboard. Okay, so my question for you, Nick, is can you see a whiteboard now?
Yeah, I can see it, and then I can also.
Okay, it looks like somebody has a hand up, so I need to figure out what's going on here in just a minute. Let me just, that's to raise the hand, so how do I'm not sure who's got their hand up. So whoever has their hand up, just go on mic and ask your question, please. And it's possible the student didn't know they'd hit the button for their hand raised, and so that's just kind of out there. Okay, now I want to explain to you why I use 125 minutes. So I'm going to be using the thing here, and I'm going to be drawing a little bit. Okay, so you have signed up for a 5. Let's see, why is that not? Do I have to pick a color? Wait, I'm just going to do it here.
So I can draw on the whiteboard myself. I think it's only for like our own like drawings. I don't think we'll be able to see. Oh wait.
Well, let's test that, because, and you may be right and you may be wrong. I'm going to type something and see if you can see it. Bear with me just for a minute. Can you see where I wrote this is a 5-hour course?
Yeah, I can. So it does work.
Okay. Now, and by the way, I'm convinced that I can also write on this in some ways, but I'll just do this because this is good enough for now. Okay. An hour is 50 minutes. Now you might say, no, an hour is 60 minutes. No, an academic hour is 50 minutes. And I think that probably goes back to, your grade school and everything else, or maybe your high school. But anyway, an hour is 50 minutes. So 5 times 50 then is equal to 250 minutes per week. So that's what a 5-hour course is. 5 times 50 is 250 minutes per week. So that is what you've paid for, and that's what you deserve, and everything else. But summer is double time. So that is 500 quality minutes of instruction per week. But we meet 5 times. No, we don't. We meet 4 times. We meet 4 times. So I divide that by, I divide 500 by 4, and that's equal to 125 quality minutes of instruction per day. Okay, and again, Nick, could you see all of that?
Yeah, it's all there.
All right, excellent. But I wanted to explain that because you see, so I did this calculation and I said, all right, we're going to be doing 125 minutes per day. Now I'm going to stop sharing this, but I am going to share my application screen again. And I'm going back to the PowerPoint slides. And you can see that we meet for 75 minutes, which is the longest anyone can listen to me for any one time. Then we'll take a 10-minute break, and then we will come back and we will meet for 50 minutes after we come back. Now, this may or may not line up exactly with what my access says, but you're getting your money's worth because 75 and 50 is 125. I'm going to pause here just, and by the way, I've learned certain techniques. I'm going to count to 5 Mississippi. And I will say Mississippi just to give people an opportunity. So if anybody has any questions about that part of things, I will count to 5 Mississippi before going on. This is a good opportunity to ask a question if you have it. Okay, no one piped up, so I'm going to assume that's good. So now we're going to begin our syllabus walkthrough. Now I am sharing my screen, so but just to be clean, I'm going to well, okay, I'm sharing my screen, and I am going to go to my screen. And I'm clicking on a syllabus tab. Actually, it's not a syllabus tab, but this is a syllabus. And so Nick, I'm sorry I'm making you work so hard, but I really do appreciate that you're doing this. Can you see a PDF on your screen now?
Yeah, I can see it.
Excellent. Okay, so this is the PDF. So we'll begin marching through this. Whenever you have questions, just go on mic and just hail me, and we can deal with your questions. I have several screens open here, and so I don't know if I'll see you if you raise your hand or not. But let's go through this then. And I am going to pause every so often to ask if you got questions, but and I know you've heard this stuff before. We're going over it once again. Okay. So this is Math 2232. This is Calculus 2. It is 5 semester hours for the summer of 2022. Now it turns out, and through no desire of my own, although I love you guys and am looking forward to teaching you guys, each and every one of you, I really didn't want to teach VCMs, but I find myself teaching 2 VCMs, and there are 2 of them that are Calc 2. The last, I am also teaching a 3rd VCM, which is linear algebra. But this is VCM02. Now, turns out that I am involved in a project where not only these 2 Math 2232s, but it also another Math 2232 that's being taught in person. We're trying to see, can we teach them in a synchronous fashion? And synchronous fashion means we're always doing the same sections and things like that, and the schedule is the same. So anyway, I'm treating these 2 courses exactly as one. So I didn't write another syllabus for 2232 VCM04. It's the same syllabus. That's why you see them both here. Okay? So that's what the syllabus is about. And this is the course description: applications of the definite integral, techniques of integration, numerical integration techniques, improper integrals, sequences and series, Taylor's and Maclaurin expansions, power series, hyperbolic functions, conics, parametric equations, and polar coordinates. And there is a prerequisite for this. Now, the prerequisite is called Math 2231 with a grade or C or better. Now, Math 2231 is a 5-hour Calculus 1 course that I've taught many times, and I've taught it recently. And this is the collegiate page prerequisite. Now, if you went to another school, and sometimes, particularly during the summer, students will be from another school and will sign up here. And sometimes all of the Calculus 1 courses in the world are not the same. And if you got in this course, if you're sitting here, you had the prerequisite, is fulfilled. But I am sort of assuming as we're going through this that everybody has took exactly Math 2231. Now, some students from another school might not have a 5-hour Calculus 1. It might have been a 4-hour. In fact, I know there are schools that have 3-hour Calculus 1, and you might find yourself in here. So there could be gaps, and there also could be overlaps because I'm basing this on what happens in 2231. So as we're going through, I fully expect that there may be gaps from students who are coming from other areas. They might say, boy, we didn't do that. Well, I'm prepared, and Jesse Hayes Carver also is prepared to deal with any gaps that might exist. And some of you might be saying, oh, we covered that in our Calculus 1 already. Well, that can happen too, because there just are different choices that people will make. So anyway, we can deal with gaps, but this is kind of the general assumption that is being made. And Nick, you can still hear me, yes?
Yeah, you're all good.
All right, great. And again, if anybody has questions, you should ask them. Now, this is a very busy course, though. We're going to be doing a lot of stuff. And these are the course objectives. And I'm not going to read all of these to you, but they are here for your record. And by the way, if you go back to, for example, a home institution, and you said, hey, I took Calculus 2 at College at DuPage, they would say, what did you learn? And so you want to say, oh, here's what we did. And so these objectives can be useful for you. I'm also going to make another comment, and my next comment is going to be that these are all action verbs. So you see, these objectives don't say kind of, sort of, understand things. It means you can use or evaluate or determine. And so these are all action verbs. So these are things I'm going to expect you to be able to do. And so that's that. And I'm just going to go down this list, and we're not going to read all these because that would not be exciting. But there's a boatload of them. It looks like there's 40 some. Oh my God, there's 40. Looks like there's 44 of these learning objectives. And we have 33 classes. So we're going to be moving briefly. Well, maybe I shouldn't say briefly, but I should say briskly. Okay, let's continue moving on. I am your instructor of record for this. We'll talk about Jesse Hayes Carver in a bit, but this is me. My given name is Patrick J. Bradley. The middle name is James, so it's Patrick James Bradley. I will tell you, my friends call me Jim. And I hope, although I am your instructor, so I'm a different kind of friend, I suppose. But you certainly can call me Jim if you want to. That's fine. And also you can call me Professor Bradley if you want. Now this is my email, and by the way, this morning I had over 8,000 emails, so there's a lot of emails there. This is the number for my office, but I'm usually not there. The place I usually am is in, well, I'm either teaching, which is what I'm doing now, and I'm actually doing a lot of that this summer. I'm working in the counseling center a little bit in the evening. And otherwise, I'm in the Learning Commons, which is SRC 2102. That's where the students are, so that's where I often am. And in fact, you can see the Student Resource Center room 2102. Actually, the 2102 should be in the next line, but is there. And I tend to hang out there whenever they're open and I'm not teaching. And so some of my office hours are on Sunday. And the other office hours from 7 a.m. to 7:50 are Zoom hours. I screwed this up. I'm not going to go back and change it either. I typed it in wrong. The 2102 should be down here. That's in the Student Resource Center. Okay, so those are my office hours, and that's who I am. And let's see, I think I introduced myself in a video, so I'm not going to bother telling you all that story again about my industry experience. Okay, so down here, then, our guided study group leader is Jesse Hayes Carver. Now, Jesse's being paid to have these guided study groups, and students who go to guided study groups do better. And a lot of times students say, oh, I'd like to study with someone. Well, you couldn't study with anyone better than Jesse Hayes Carver. So Jesse Hayes Carver is your guided study group leader. Okay. Nick, we still good?
Yeah, all good.
All right. And I'm sorry, Nick, but I've done this before, and I talked for 20 minutes, and then I realized no one was there for 20 minutes. So, okay. So we're going on then. I used a different word than the bookstore used, and some students have asked about this, so I want to be clear about the different word. The math department at the College of DuPage spends a lot of time worrying about what they think are the right textbooks and things like that for us to use for courses. And the bookstore wants to sell these books. But particularly during the summer, and particularly in Calculus 2, students will say, well, gee, I took Calculus 1 at, I'm going to make up a school, UIC, and now I'm going to the College of DuPage. You mean I have to buy another calculus book? Well, the answer is no, you don't. All calculus books are pretty much the same. But these are the books that the bookstore will say are required. They're not required. You can get by without them, or you can get by using other books. And actually, I pride myself on providing good notes as well. So I think, it's not saying, oh, no, damn it, you have to go and buy this. But I am going to talk about what the books are. So there's a pre-calculus custom book here, and we just use this for one topic in the course, which is the rotation of axes of conics. I'm going to give good notes on that. And so, I mean, you certainly can buy this if you want, but you don't have to. And there's many places that you can get that. And in fact, if you're using Stewart's calculus book, I was going to say it's in the book. I'm actually not sure about that. But anyway, this is for one topic and one topic only. Now, we are talking about the Thomas Calculus series. This is the 14th edition, and this is the textbook of reference. This is the endorsed textbook. But if you have something else, or sometimes students come in and say, you know, Jim, I have the 13th edition. Do I have to buy the 14th? And I'm going to say, no, you don't. And by the way, these books are available many places, including the Learning Commons, and so you can go in there and look at books there if you want to as well. So those are the endorsed books, not the required books. And when I say required, that's like, and later on in this lecture, I will say required. And when I say required there, I mean required. You've got to do it. Here you don't. Got to do it. I'm going to pause for a moment because some students were writing me all kinds of emails. And let me say this too. A lot of times I'll get the same email fundamentally from 10 students. And so I'll sometimes answer that during class or something instead of answering, the 10 individual emails. But some students have asked questions about books. So I'm going to pause here for a count of 5 Mississippi in case people have questions that they want to ask about the textbook. Okay, I made it to 5 and no one raised their hands. So, all right. Actually, I don't know if you raised your hands or not, but no one spoke out, which is what we probably should do in this environment. This is a boilerplate thing about academic honesty, but I am going to tell you this is a really big topic. And in fact, I serve on the Academic Integrity Committee at the college. And this says it's a partnership between faculty and students. Well, I got to tell you, this is a work in progress. And in mathematics, it's very important that and I talked about high stakes assessment, our high stakes assessments will be proctored. and I'm working very hard to set up schema for proctoring, but you want to follow the rules because this is a big deal. Not only do I sometimes get upset if students violate academic honesty kinds of things, I don't like it for another reason too, and that is that I have to go to meetings and I have to fill out forms and stuff like that. I hate filling out forms. And so, follow the guidelines is what I'm really saying there. Access and accommodations, you can read that, but if you have accommodations from high school IEPs or otherwise, I will honor them. In fact, Jesse Hayes Carver and I are almost legendary in our willingness to accommodate students. In fact, sometimes people shake their heads and say, I can't believe you did that for that student. But I also do have boundaries, and so just realize that those are there. Those are kind of boilerplate. Now what I'm going to do is I'm going to go to a thing that's called grades and such. So we'll talk a little bit about this. I have thought long and hard about what is important to me. And to me, the most important thing is down here, teaching you the very best content course possible. And Jesse Hayes Carver knows this is my prime objective, and we share this objective. So if you said, Jim, what's your number one thing? It's going to be teaching you the very best content course possible. That's our number one thing. And it's number one by several orders of magnitude. My number two thing, and I only have three, my number two thing is that I want to be sensitive and seek to accommodate students where I can. Now, that does have boundaries, but that's my number two thing. But my number three thing is, and this is important for you to understand, and this is why I'm talking about it now, is within a wholesome discipline, I render grades gently. Now, in Calculus 2, and in fact in the calculus sequence, a wholesome discipline has some serious meaning. And you see, if I'm teaching you Calculus 1, I can't give you a pass into Calculus 2, which was a C or better, if you're not ready for that. I'm not doing anyone a favor. I'm not doing you a favor because you would fail in Calculus 2. I'm also not doing a Calculus 2 instructor a favor by giving them someone who is woefully unprepared. And the same thing is true about Calculus 2, because Calculus 2 is a prerequisite for Calculus 3 and other courses as well. It's a prerequisite for linear algebra, for example, which I'm teaching this summer. It's a prerequisite for differential equations and so on and so forth. So grades are serious here, and you're not just going to sign your name on a piece of paper and say, oh yeah, and I get a C for that, right? I always did before. Well, I don't know what happened before, but that's not what's going to happen in this course. Now, I'm not trying to be mean or anything else, because remember my number two said I wanted to be sensitive to students' needs, but grades will be rendered, fairly, I'm going to say here, but rigorously. Okay, so now I'm prepared to talk about grades and such, because I do have to give you grades. In my dream world, I just would go in, teach a good course, you guys would learn what you could, and then you would, and then we'd part company. But I have to give you grades, okay? And so that's one of my costs. So this is about grades and such. Now, my number one advice to you, and I really mean this, is if you focus on learning the material, really learning the material, the grades will care for themselves. That's really true. A lot of students don't believe this. They say, oh, I've had to fight for every point I've ever had in a math class. Well, that's not really it. Focus on learning the material, really learning the material, and the grades will care for themselves. Okay, now there has to be some kind of a mechanism here. Here's my mechanism. There will be three primary and equally weighted grading components in this course. There will be things that are called low stakes assessments. And low stakes assessments normally are either homework problems that I assign, and maybe there'll be a little bit more involved homework problems that I will give you. And you can get help on these homework problems, and it's not turning them in tomorrow. But I will collect them and things like that. So it'll be a bunch of these low stakes assessment. Again, these are take-home protocols, so you could get help. You could go and you could meet with Jesse Hayes Carver if you wanted to, and he could, you know, do this. Now, Jesse Hayes Carver is not going to tell you, oh, Sam, the answer is 5. I don't know if there's a Sam in this course. I was not really talking about anyway. That's a hypothetical Sam. You know, he's not going to say that, but he might say, oh, well, have you tried this? And look at this. And Jesse is actually very skilled at helping students find their way along this. And there are many other resources too that we'll talk about, including my office hours. So I know there'll be a series of these low stakes assessments. And also I sometimes start the class with what I call an unquiz. And tomorrow, because we meet tomorrow, I plan to have an unquiz for you. Now that means when you come at 8 o'clock, there will be an unquiz sitting there for you to do. Now, notice that I'm calling this an unquiz. And the reason I'm calling this an unquiz is it has all the benefits of a quiz and none of the negatives associated with a quiz. And by that, I mean, it will be like one problem. It will be something that we talked about today, or recently anyway. It gives you some exposure to the kind of questions I might ask on an exam. It gives you an opportunity to test, do you really know how to do this? But I don't grade it. You grade it. And you grade it. And you walk away saying, oh, did I really understand that or not? And you might, in fact, keep a notebook of these unquizzes and say, yeah, those are the kind of problems Jim might ask on a test. And so you get kind of a catalog of such things. So anyway, there are low stakes assessments, which are either assigned low stakes assessments like I talked about, and or the unquizzes. And the unquizzes will happen frequently, almost every period. And like what I said is, if you're here at 8 o'clock, as you should be, maybe I give you till 8:05, and then I say, okay, let's go over the unquiz, or maybe it's 8:10, depending on how involved the unquiz is. Okay, so all right, so low stakes assessments are going to be a pile of points. Don't ask me how many there will be, because I don't know how many it'll be. It'll depend on how things play out during the term. I'll say there might be one a week, but actually I'm not even sure about that. We'll see how many of those are. We will talk about more routine homework problems in a bit. But anyway, they're a low stakes assessment. And so I will have some numbers that I can normalize to 100 points. So like suppose that there were 700 points here, and someone got 700 out of 700. I say, oh, you got 100 points, 100% on your low stakes assessments. But then we will have two things that are called high stakes assessments. And the one high stakes assessment will happen more or less at midterm. And in fact, I'm going to be more explicit than more or less during this presentation about the syllabus. I'm sorry this is taking so long, but I think it's important to do this. Okay, so this is going to be a proctored exam, and there'll be 100 points possible. I'll normalize it to 100 points. And so that'll happen more or less around midterm. And then at the end of this term, our time together, there will be what I call a high stakes assessment, a final exam high stakes assessment, and this will be comprehensive. And in fact, the midterm is comprehensive too. So both these exams really are comprehensive. It's everything up to that point. This will be normalized to 100 points. And there is a rigorous scale, because you've got to have developed your skill set and understand the tradecraft to be successful going on in calculus. So this is a pretty rich thing. In fact, there was a student who had me for Calculus 1, and this student that I'm thinking of did actually quite well in the course. And they said, I did good in the course. Why didn't I get an A? Well, they didn't get an A because their overall average was 83. and they got an 87 on the final. That puts them squarely in the B range. I also told them, though, hey, B's a pretty good score. You did well. You did do well in the course. Okay, so anyway, there you can kind of see the scale and things like that. Nick, if you can still hear me, I'm going to pause for a count of 5, Mississippi. Can you still hear me?
Yeah, I can still hear you.
All right, great. Nick can still hear me. That means I'm going to assume everybody can. I'm going to count to 10, Mississippi, because for many students this is a big deal. Okay, people aren't asking questions. I don't know what that means. I don't know if that means I'm doing a good job explaining things or I've totally baffled people. Okay. Now here is our plan. Now, normally I don't even write something like this down because I know what I can do and I can fly very well by the seat of my pants. But as I told you, I am participating in a little experiment where we're trying to synchronize the Calculus 2 during the summer. And so I agreed to this plan. And this plan is something that the group of people, put together, and they said, hey, will you do this with us? And I said, sure, I will. Now, I am doing it, but also I'm doing it a little bit differently. So you see, we meet for 8 weeks. And, it just goes on and on and on. Okay, so these are the sections that we're targeting to cover in the textbook. And I'm going to be talking about this section 5.6 today, okay, and so on and so forth. So this is, their master schedule. I don't think I'll have any problem sticking with this, and in fact, maybe accelerating from that. Now, they are not teaching, they're teaching the classes I sort of wanted to teach. They're teaching them inside a classroom. And by the way, it doesn't mean I don't want to teach you. I do, and I know how to do this. This will be just fine. But they're going to have a test on June 29th. You're not going to have a test on June 29th because you're a VCM. We have to do it. I have to do it differently here. There is no class on July 4th. And so then we come down here, and this is different too. They, the other Calc 2 class that's part of this trial, are going to be having a second exam on July 13th. You are not having a second exam on July 13th. What I do is I give you, because we have proctoring arrangements that are set up, so I am giving you a window of time to do the midterm. So the shaded area that you see here from July 11th to actually, that goes even, let's see, 1, 2, 3, 4. And that, so let's see, that's 11, 12, 13, 14. So July 11 through July 14th is the interval during which you can take the midterm. But you have to take it in a proctored environment. I'll explain that later. But some students have been asking me, they say, oh, when's the test? Because I'm doing this vacation thing or stuff. I had so many emails about that. I'm just telling you, if you go on vacation, that's fine. I hope you can do this kind of thing. If you say, oh, I absolutely can't, then we can interact and try to come up with accommodations. But what I really expect is, since this is online or can be online, and since this is proctored, you can kind of have a great deal of flexibility. So you could be on vacation and still do this, and that would be fine. Okay, and then going along, what happens is the group is having I guess that's a third exam on July 27th. We are not having an exam on July 27th because we're only having a midterm and a final. But our final exam window of time for taking it, the shaded area here from August 1st to August 4th, this is the final exam interval. This is when I expect you to take the exam, either in person, being proctored, or virtually. And we'll say more about the details of how you do that. But those are the exam windows. Okay, so there's been a number of students who've sent me emails saying, oh, I have this thing, so I need to know exactly when the tests are going to be and I didn't answer it because this actually is a lot to explain. And in fact, I'm not finished explaining it yet, but I'm working through this. So what happens is the shaded area is the midterm testing interval, and the shaded area down here is the final exam testing interval. Now I'm going to say more about how that testing happens a little bit more today and more as we go forward. Are there, I'm going to pause. Nick, you can still hear me.
Yep, you're good.
All right, great. Thank you, Nick. Okay, so I'm going to count to 10, Mississippi, in case anybody's got any questions about this. Otherwise, I'm going to say, hey, that's covered. Okay, sometimes I'm scared. I don't know what that means. Oh, and then that working group who was trying to do this came up with what they call a minimal problem set. Now you want to do more problems than this, or enough problems that you get good at what's happening. I'm not picking these up, but it's assumed that you do them. And so you can see that these various sections in your book have assigned problems there. I got to tell you, I normally don't do this because I have a problem that students say, oh, well, you mean the test is exactly like one of these problems? No, not necessarily. I mean, I'll tell you a good study guide for the test, but it's not going to be you show up the day before the test and I give you exactly the test except maybe for one number being changed. No, what you want to do is engage immediately, be keeping up with this, and this is the minimum problem set. Okay. Low stakes assessments and unquizzes will be separately assigned, and I expect to have an unquiz tomorrow. And you'll kind of know what the unquizzes are, but they're set up to have all the benefits of having a quiz with none of the negatives of having them. I should mention here, I guess I do mention, that the midterm and final exams are mandatory class requirements. The course cannot be passed without them. And then I'm saying more about the testing now. These will either be administered in a COD testing center. That's if you physically can come to the testing center. And by the way, the testing centers require masks and there's separation happens. So they're really, they're really safe. But I have had students who have taken course with me from Dubai and places like that, and they cannot commute. Even if they are a Saudi prince, they are not going to commute from Dubai to Glen Ellen to take a test. But by the way, I am encouraging you to take these in the testing center because that's really the best way to take them. But there are other ways that there are separate virtual testing centers that can be administered. But here's the deal. And this is different than what happened during the early days of COVID. During the early days of COVID, I really, frankly, exhausted myself accommodating each and every student, and it went really nuts. And in fact, I ended up, I think, making someone in the testing center hospitalized because it was so awkwardly done. So anyway, it's a more rigorous process now, but the student is going to be responsible for scheduling such an accommodation themselves with the testing center. So going back up here, so let's suppose somebody is in Dubai, and so they cannot come to the Glen Ellen testing center or any of the testing centers. They use the process that I'm going to do, and they make arrangements to say, okay, on July 14th at a certain time, I will show up and I will take this in a Zoom environment. And there's a lot more involved in here. We've done this before. It does work. It does work well, but you are being proctored. Okay, so going ahead to that then, so where are we? Oh, okay. The student, you are responsible for scheduling such an accommodation with the testing center, because I'm setting up these processes. Now, this is a work in progress, and I'm going to say a little bit more about this, but along the way you might say, hey, I don't have all the details. Well, you're not going to have all the details because this is the first day of class, but details will be coming, okay? And the last thing, oops, wait a minute. Holy cow. This, doesn't have what I wanted to show. So, all right, so I'm going to say more about this now. And so, Nick, this means, Nick, I'm going to be asking you what you see in just a bit, but I'm changing channels. So I'm going back to this, but this isn't what I want. And I wanted to go back to, oh God, can I go back to Blackboard that way? I'm going to try to go Blackboard. This is a little bit risky what I'm doing here. I could lose you. That's not it. So I'm going to go to my institution, and I'm going to go to, that's wrong, here. Here. Actually, that's not it either. I'm just going to wing this for right now. I think I did this in a video. There are 6 testing centers. In fact, I know I did this in a video. And let me try to get back to where I wanted to be. Okay, Nick, are we back on the lecture 1 slide again?
Yeah.
Good, thank you. Okay, we really finished this. There are, I'm just going to say more about that later, but now I want to pause because we finished the syllabus walkthrough. I think I've covered everything. I covered some things better in the videos than I just did now, but anyway, it's all there. So okay, are there any questions? I'll count to 10, Mississippi, and then we'll go on. So someone has a question. Someone's doing something. I guess they're raising their hand. Oh, I see. It's Leon. So Leon, I'm hitting lower your hand, but I'm going to ask you to go off mic and tell me what your question is. So Leon, there's a little microphone that you have to change. All right, here's a chat. Let's see what somebody said. Just to be clear, we are not required to buy textbooks for this course, right? And I think this was Leon's question, actually. So now I can see it. And so, yes, that's correct, Leon. I am not requiring you to buy textbooks for this course. But, Leon, and not just Leon, but everybody, I'm expecting you to be able to do what I ask you to do. And if you can't do it, that's not a good thing. So make sure that you are, but I'm not requiring you to buy it. And so, Leon, I hope that answers your question. There was another hand raised here, and I'm trying to figure out how to get at the hands that are raised. That doesn't help. Okay, if there's another student who has their hand up and you want to go off mic or share, wait, there's another chat message now, hold on. So I have to bounce back and forth. Tori, I will be with you in just a second. Okay, Leon said fantastic. Now, Tori, you can go on the mic. That's actually my preference, is for you to answer. And there's some hands that are up here, and So anyway, Tori, your hand was up. So go ahead and ask your question if you can. So Tori might be having, oh wait, here she is. Now, Tori, there's a little red button there. Yes, now, Tori, I should be able to hear you. Thank you. And Tori, I don't know if your mic's not working or what, but I'm not hearing anything. Can you type it in the chat, Tori? I guess we have to do chats. I'm sorry, Tori, I can't hear you. Oh, here it is. I guess my mic's not working, but I don't have a question. Okay, for some reason you showed up as a hand raised, Tori, but that's fine. And you can always ask questions in the chat, except looking at chats and all these. I have like 4 screens open, so it's hard to do. But she didn't have a question. There are 3 other hands that supposedly are raised. Do any of you have a question? Okay, I guess I'm just going to assume that those people accidentally hit their hand raised buttons and don't even know that they have it. And I'm not being mean when I'm saying that. It's just this whole thing is a bit awkward. Okay. What is the attendance policy for this course? One of your classmates asked that. I don't give you points just for coming to class. So your grade will be determined based on how you do on the unquizzes. It'll be based on how you do in the LSAs. It'll be based on how you do on the high stakes assessments. I will tell you that students who attend the class do much better than students who don't go to class because actually Jesse Hayes Carver and I are very experienced and actually very good at what we do. But no, I'm not grading you on that. So that was my answer for the question about attendance policies. Are the lectures recorded? It's being recorded right now. And by the way, it's a little bit messy and awkward for me to turn it off during the break. We will be taking a break in about 22 minutes. And I'm just going to let it run through the break, but you can fast forward. I'm going to post these on YouTube. You can fast forward on YouTube to through a break if they're there. Okay, I'm going to repeat myself. It says, do you deduct our points for not attending on time? This is not high school. I don't grade you on attendance, but I do grade you on something that's much more important. Do you understand, and can you do the problems? So I'm not deducting problems. Some students say, oh, I just won't go to this class. And I'll pull an all-nighter before the midterm and an all-nighter before the final exam. That won't work very well in a math course. Anyway, no, I'm not deducting points for attending. My time is too important to spend my time taking attendance. Okay. I hope that answered that question about attendance things. Okay, so some people think they got their questions answered, so that was good. All right, your questions are always welcome, but I think I'm going to declare this segment of that discussion finished. And now what we're going to do is we're going to go into some work. And I will be watching the clock. I won't lose track of what's happening, so there will be a break coming. So if you're saying, oh, gee, I've got to go to the bathroom pretty soon, well, if you can hold it for 20 minutes, you're good. Okay, so now what we're going to do then is I'm going to, let's see, I'm going to go back to, I'm going to stop sharing for a moment, and then I'm going to share again. I'm sharing my entire application screen with you, and I'm going to minimize this thing. And okay, so you should be, Nick, looking at lecture 1 slide still again, and you can see it?
Yeah, you're good.
Okay, great. So we did questions, and now we're going to begin work. Now, one of the things that will happen now is the rest of this is just a block of math. And what we're going to be doing is we're going to be checkpointing, and at the end, I'll wish you well and dismiss you. I have kind of a standard way to dismiss you, so you know when I'm done with you. And also, one of the things I'll do, I might not do this in the class, but also letting people know, well, okay, so where are we in the book? Okay, so now I'm going to leap into some lecturing, I guess, more traditional lecturing. So we move to the next slide, and this is our first topic. Now, this is the area of a region between two curves. Now, some of you might say, oh, wait, I did this in Calculus 1. I already know this. Well, okay, but you got to be able to do the problems here. And it is a little bit of accident of history that this is part of Calculus 2 and not part of Calculus 1 at the College of DuPage. I will tell you that I teach, recently I've taught Calculus 1 at the College of DuPage, and I in fact covered this topic in my Calculus 1, but I'm supposed to cover it in Calculus 2. I'm part of this team who's trying to be synchronized, so we're going to do this. So in this lecture then, what I'm going to be doing is I'm going to be talking about, and by the way, I'm going to change this so I can actually see the clock better. Okay, so instead of having this in power slide mode, I've got it this way. We're going to talk about finding the area of a region between two curves using integration, finding the area of a region between intersecting curves using integration, and describing integration as an accumulation process. So that's what's going to be happening here. Okay, so let's go to this one. I think I can actually jump back and forth, so I'll just do that. I'll keep track of things. Okay, and if we were in class, I would probably ask you to read, but we'll talk a little bit about this. Okay, so what is happening here, and this is if you took Calculus 1 according to the standard thing at the College of DuPage. With a few modifications, you can extend the application of definite integrals from the area under a curve to the area of a region between two curves. So we're going to consider two functions, f and g, and here's a little picture. So f is this dark function, and g is the gray function. Nick, you can still see what I'm talking about, right?
Yep.
Okay, and some of you might just say, poor Nick, Jim's taking attendance with Nick. No, I'm not. Nick agreed to do this, and he, you know, I appreciate him for doing this, and I'll probably move this on to other people. But anyway, he can see this. Okay. All right, so we're taking f and g, and these are both continuous functions on the interval AB. This is A, and this is B. I'm not sure you can see that or not, but that goes from A to B. Okay, and so if you want to know the area between these two curves, so it's this kind of, I don't know, puce colored thing in between. That's what we're trying to figure out the area of. And so it's the area of the region between the graphs as the area under the graph of G subtracted from the area under A. So so anyway, that's what we're about here, is determining that area. Now, and so you can see here, and if you look at this picture, this is actually a pretty good picture, because here is A, here is B, and you see you've got this area under region G, which here's the function G is this one. This is the area under G. So you see that's what we're going to be subtracting off, because there's the minus sign. But here is F, and if we look at the area under F, And again, f in this case is positive. You go from A to B. So it's all of this area, including what's there. But then if you subtract this area from this area, you get the area you wanted. Okay, so this kind of says it all, that the integral from A to B of f of x minus g of x dx, this is the area of the region between f and g, and f is the one that's on top. So this is always positive. And that's the integral of f minus the integral of g. Now, we do talk a little bit about demonstrating that that's reasonable. And you see, and we do draw slices a lot in this course, and I will encourage students to draw slices, because you can say, well, okay, if I were trying to approximate this with rectangles, I draw a little rectangle that looks like this. And notice that this is a vertical rectangle, but when it's a vertical rectangle, the thing that's happening here is delta x. So you see x sub I is some point here. And so this is g of x sub I, and this is f of x sub I. So the height of this rectangle is f of x sub I minus g of x sub I, and the width is something that we will call delta x, and you talked about delta x's before. So adding the areas of the rectangles together, and then we take a limit, because calculus is the study of limits, and this is the limit as the norm of the partition goes to 0. Now the norm of the partition, you might remember from your calculus 1, you don't have to, but as the norm of this partition goes to 0, that means the largest chunk goes to 0, and that means that's equivalent. We show this in Calc 1, that this is that the number of little rectangles goes to infinity. You obtain this, and this is the limit as n goes to infinity. You add up all those rectangles, and this is that's not absolute value. Those are just parentheses because f is on top. That's f of x sub I minus g of x sub I times delta x. But when you take this limit is known to be the definite integral. So this is the integral from a to b of f of x minus g of x dx. So we come to a I don't know, a theorem or something. You maybe want to write it down. And what this is saying is that if f and g are continuous on AB, and f of x is on top, and it is important to remember who is on top. So f of x is bigger than or equal to g of x in the entire interval. Then the area bounded by the graphs of f and g and the vertical lines a and b is, and it's the integral of from a to b of f of x minus g of x, and that is dx. Okay, now I think we're about ready to jump in and do some examples, but I'm going to double check and see what time it is. We're in really good shape. So I'm going to pause for a count of 5 Mississippi in case there's questions. And please realize your questions are always welcome, not just when I ask for them, but they're certainly always welcome. So I'm going to count to 5 Mississippi.
Hi, there's a box at the bottom of the screen that says stop sharing and hide. Could you try hitting hide and seeing if that box goes away?
I can try that, and the only risk in doing that is that I'll have to talk to Nick some more. I will do that. Now, what I did there, though, is I went up here. I recognized that that was there, and it is a little bit of a good box because it tells me what's going on. But that's okay, and I do appreciate the comment. But I went up here and I sort of said that in words whenever it was happening. So I went back up here, and you see this is actually the area is that thing, and that's what it says the area is there. But okay, so are we good with this? Okay, all right, so we're just going to keep moving on then, and let's do an example.
Excuse me?
Yes, go ahead. I'm sorry.
Before you go ahead, I just wanted to inquire, like after the classes, will you be providing the PowerPoints? Like the PowerPoint presentations in like Blackboard?
I will be, I mean, this is, my mother used to say that the road to hell is paved with good intentions, but I intend to publish both the video of this and what I call talking points. And
Okay.
talking points will represent how far we go. So the short answer, I think, is yes.
Okay.
But I will tell you that some students, and I'm not accusing you of this, but some students say, oh, I don't have to go to class, I'll just watch the video, and maybe I'll just read the slides or something like that. My intent is that you are able to do this, but actually I don't know. I think it's very worthwhile coming to class. So anyway, but that's the answer to that. And Nick, you're looking at something that has a figure 7.4 in it.
Yeah.
Okay. Now, some students might say, well, yeah, but is that always going to work? Because sometimes this thing could be negative. Well, it does work because, and I'm going down here looking at figure 7.4, I'm just talking about this. You see that the integral from a to b of g of x is going to be a negative number. So you see, if you subtract the guy on top minus the guy on bottom, it turns out your minus a minus is a plus. So this formula works whether you're above the axis or below the axis. But what is important is that f is the guy that's on top. Okay, I think we talked enough about that. So here is the first example. We are going to do this example. We will finish this example before we take a break, but I'm confident that we will. And these examples are important because you want to understand the examples. You also want to understand the unquizzes. You understand the LSAs. You want to do homework because all those things make you stronger, make you better able to do things. So example 1 here says we're going to find the area of a region between two curves. So here's the statement of the problem. Now, by the way, the statement of the problem on a test or something would be just these words down here. So it says find the area of the region bounded by the graphs of y equal x squared plus 2, y equal minus x, x equals 0, and x equal 1. Now, if we were in a classroom, I probably would pause, and if we didn't have to talk about the syllabus today, I would just pause and I'd say, hey, try to do this, then we'll go through this together. But now what I'm going to tell you is this is what you need to do. You need to understand what to do here, and you need to be able to sketch a graph of these functions. And in fact, you're going to talk about, you want to sketch this entire region where y equals x squared plus 2, y equal minus x, x equals 0, and x equal 1. Now, I'm not going to spend time trying to do this at VCM because, frankly, I've learned that a bunch of students just start playing with their cell phones and they don't pay any attention and they don't try to do it. It is to your advantage to try to do this. Okay, so here we've drawn a picture. This is in the right-hand panel of what you're looking at there. And so this is f of x equal x squared plus 2. You have to be able to graph this. You're not using technology to graph this, okay? I think there was a technology statement in that syllabus as well. But anyway, we're not going to have a lot of technology available in proctored exams. So you have to be able to graph that. And this is the graph of y equal g of x equal minus x. So we draw those, and the problem told us that we were going from 0 to 1. So you see the area that we're trying to find is the area that's colored, well, I mean, there's a representative rectangle, and thinking about that slice is good because when you draw that slice, that tells you immediately that this is dx we're going to be doing. So what we're going to be doing is we're going to be going from 0 to 1. F of x is this function over here. G of x is this function over here. So the area of the region is the integral from a to b of f of x minus g of x dx, the top one minus the bottom one. And then this is going to be, the top one is the whole of x squared plus 2 minus the whole of g of x. Now, I'm making a big deal of saying the whole of because I've taught this course many times. This is what students often screw up. Is you're subtracting the whole of g of x. But g of x was minus x. So this is minus a minus x, which is a plus x. So now we have what we need to integrate. Now, I do expect you to do the integrals. This is all about doing the integrals, so we're reviewing this just a little bit. Now, when you do a minus times a minus, that's going to be a plus. And so we go through. So when you integrate x squared, you add 1 to the exponent, divide by the new exponent, that is x cubed over 3, plus we come to, let's see, we're integrating 2, and we're integrating 2, that's 2x to the 0, so you add 1 to the exponent, divide by the new exponent, which is 1 again, so that is just 2x. And then here it was plus x, so you add 1 to the exponent, that's x squared over 2, divide by the new exponent, and then you have to plug in numbers. Now, we're not going to be using calculators on the high stakes assessment. That is a math department policy at the College of DuPage, so you have to plug in numbers. Now, plugging in 0 is very easy. Plugging in 1 is also easy, but now you have to be able to add fractions, and the exact answer is 17 over 6. Now, I am going to pause for a count of 5 Mississippi in case students want to ask questions about this example. Okay, so you see, I expect you to be able to do this problem starting with the graphing without a calculator all the way to getting 17 over 6. And that's what's going to get you full credit for this problem.
So
Okay.
I don't.
Oh,
Oh,
someone
sorry.
has a question. Go ahead.
Sorry, it took me a second to get my mute button. So I don't really understand how we got from step 2 to 3. I'm assuming this is something. So I took Calc 1 in 2004, so it's been a while. But I'm assuming that's where, for me, that's the trouble spot. So what do I need to study to
I'm
get
going,
from step
I'm
2
going
to
to
3?
guess. Now, I have to guess because you said step 2 and step 3. So I tell you what I'm going to do, and I've got 4 minutes to do it, so this is fine. I'm going to talk through this, and I think I'm going to cover your question in my comments. And I'll probably say more than your question, but that's kind of okay. And by the way, thank you for asking a question. Sometimes students are too shy, and it's your right. In fact, more than that, it's your duty as a student to ask questions. But anyway, we go down here to this. Okay, so I made an argument that the area under the curve is going to be the integral from a to b of f of x, that's the top guy, minus the bottom guy, dx. So then this is going to be the integral. Now, we knew from the problem that a was 0 and b was 1. So this is the integral from 0 to 1 of, and the top function, f of x, is, I'm going up here and wiggling my cursor. I'm not sure you can see me wiggling my cursor. I hope you can. But anyway, you go up here to the top, and so the top function is x squared plus 2. So I write x squared plus 2 right there. And then it's minus, this minus sign is this minus sign. But then I'm subtracting off g of x. And again, I say, because I think it's important to emphasize this for students, because a lot of students screw this up, you're subtracting off the whole of g of x. So you see this minus sign is there, but g of x itself has a minus sign, so it's minus a minus, which is a plus. Now, if I do algebra on this then, and sometimes you integrate things and then you do algebra, sometimes you do algebra, then you integrate things. By the way, I will give you your full break, but if I have to go a little bit over to finish this, I'll do that. I'll just keep track of things. It will be fine. You still will get your 10-minute break. Okay, so we're integrating from 0 to 1. And so this is x squared plus 2, and minus is plus. Now, the notes that I provide here do a little bit of a goofy thing, but I'll do it one step at a time. So to calculate this integral then, and by the way, this is fair that you have to know from Calc 1. Now, if you don't remember it, it can be okay, but you have to say, oh no, I've got to go back and remember this. But you have to integrate x squared. When you integrate x squared, you add 1 to the exponent, divide by the new exponent, that is x cubed over 3. So there's the x cubed over 3 sitting right there. Now this is 2x to the 0. So the 2 just sits there, you pull it through the integral sign, you add 1 to the exponent, divide by the new exponent, this becomes 2x. And they wrote the 2x over here. And that might be confusing for some. And then I told you this was plus x. So plus x, that's plus x to the 1. So I add 1 to the exponent, that is x squared, divided by the new exponent, which is x squared. But then I use the fundamental theorem of calculus from calculus 1. And this is going to be, I plug in the 1 into all of that business. Then I plug in the 0 into all of that business. Now, plugging in the 0 into all of that business, I get a 0. If I plug in a 1, I get 1/3. from there, I get 1/2 from there, and I get 2 from there. I add all those things up without a calculator on a high stakes assessment, and I get 17/6. I'm hoping that answered your question somehow.
Yes. So yes, I know what I need to study. Thank you.
Okay, good. And by the way, study that sooner rather than later because, and that's another reason sometimes it's useful to have a calculus book because you can look back in other chapters and figure that out. But yeah, I expect you to be able to do this problem. Okay, now I am about ready to declare a break. So I'm calling this, and this is by my clock, but I'm calling this, it is 9:15, but I'm calling it 9:16. And that means at 9:26, I will start talking again. Now we're going to be dead for that time. So, if you want to go get a cup of coffee or something, don't drive to Starbucks because you won't have time for that. But we'll continue this right where we left off when we reconvene. And we reconvene at 9:26. Talk to you then.
I'm just raising my hand because I wanted to clarify something once you were ready. That's all.
Oh, okay, Dale. Let's. In fact, I think it's ready to go. So, Dale, what is your I don't know, question or what?
Yeah. Can you bring back up the problem we just looked through?
I think so. Can
There
you
it is.
see it?
Yes, I can. So, and I'm looking at the bottom where there's like 1, 2, 3, 4, 5 steps to get to 17 sixths, 17 divided by 6. And so between steps 3 and 4 there, you plugged in the 1 and then you plugged in the 0, and plugging in the 0 just got you a bunch of zeros. I think I'm understanding this. But again, I just don't remember integration at all, and I have to go back and study this. Are we plugging 1 and 0 in and then taking the sum of all of that? Is that what's going on here?
Okay. I'm going to go. Okay, so I need to go back to here, and I'm going to share something else with you, Dale, and everybody else. I'm sharing a blank whiteboard. Now, it turns out that this has a bunch of stuff that I did before, so I'm going to clear all of it. Okay, and I'm going to see if I can figure out how to draw on this. So I want to do drawing. And I think it maybe makes me pick colors or something. Yes, it does. That's the deal. Okay, so now I have color, so I'm drawing here. Now, this drawing will look like I am a 2-year-old, okay? But that's, okay, so the integral, I don't know why that, shit. I hate this stuff, actually. Okay, so they try to make it better, but it often isn't. Oh, maybe this is what I need. Okay, now we'll try it. This may or may not work. I don't know why it's shading. Yeah, I know why it's shading because I picked the shading button. So we'll erase all of that. I'm going to say some things, Dale, okay, and just pretend I'm writing them. The fundamental theorem of calculus says that the definite integral from a to b of f of x dx is equal to, and by the way, I'm going to say that again. The definite integral from a to b of lowercase f of x dx is equal to capital F of b minus capital F of a. And that is when capital F of a is an antiderivative of lowercase f of x. And so that means that capital F prime of x is equal to f of x. So that's the step I think you might be missing.
Yeah, that sounds right. So it's not the sum; it was the difference. I think I'm following.
Okay, good. So that's probably the best I can do because I'm actually better on the Zoom thing, I think. Okay, so I'm going to share now back the application screen, and we're back together. And I'm going to poll Nick again just to see, not yet Nick, but almost. We're going back here, and this is the problem we just finished.
Yeah, you're good.
Nick, you can see that problem?
Yeah, you're good.
Great. Okay, we're going on to the next problem then, because a lot of what we do in this class is one problem after another. And I do see that screen sharing thing is down there, and I will be sensitive to that, and I can turn that off if we do something. But let's go to another problem, okay? So here's the next problem, and again, the statement of the problem. And someone said, oh, you're going to post these so I don't have to pay any attention now, or maybe just occasionally take a picture of things. I encourage you to write things down and actually take notes if you're here. People don't, some young people don't believe this, but there actually are psychological studies that show that that's better. Okay, so here we're going to want to find the area of the region bounded by the graphs of f of x equal 2 minus x squared and g of x equal x. And just so you guys know what's happening, I am going to be watching what the time is, and we'll be going until 9:15. You see, I went 1 minute over at the start, so we started 1 minute later. This all balances out. You're getting exactly what you want. But I will bring the class to a close more or less at 10:15. So this is the problem we're doing. Find the area of the region bounded by the graphs of f of x equal 2 minus x squared and g of x equal x. Now, that's the area bounded by those things. So first order of business is you need to draw a graph of this. And you need to be able to sketch this without a calculator. So here we go. So you can see in the left-hand side of this slide, I have a graph. And again, I've drawn this slice, and this slice actually is a very useful thing to do. It's useful now, but it's also useful others, because when we draw that vertical slice, it's very clear that we're integrating dx. So that's a very important thing. And we draw the picture, and you can see that indeed the area between these two curves is going to be this, I'll call it pink this time. I think I called it puce before, and I'm not even sure I know what puce is as a color. So anyway, it is a kind of a cream colored thing. And that's what we're trying to find, is that area. But we have to do a couple of things to do that. First of all, we have to realize that the f of x is on the top and the g of x is on the bottom. We have to set up that equation that we've just memorized, that the area is the integral from a to b of f of x minus g of x, where f of x is on top. But you see, in this problem, we don't know what our limits are. So first step is graphing it, but then we have to say, oh, no one told us what the limits are. Well, the limits are clearly going to be the points of intersection of f of x and g of x. So we have to find out what those are. So there's the picture. That's probably the first step. But now we need to find out, we want to find the, I'm wiggling my cursor now on the right side of the screen. So we want to find the x coordinates of these points. So you see, the way to do that, and the reason we need to find the x coordinates is because we're integrating dx. So we're going to set f of x and g of x equal to one another and solve for x. So this was the thing we called f of x. This is the thing we called g of x. And to solve this, we have to solve a quadratic. So we're going to get everything on one side of the equal sign. We're going to get everything on the left side. And that means we're going to be subtracting the x from both sides. So we get minus x squared minus x plus 2 is equal to 0. All right, now if you're lucky, this will factor. And if you're unlucky, you'll have to use a quadratic formula or something like that. And the expectation is that you know the quadratic formula, and the expectation is that you know how to factor. So anyway, but we have this. I will tell you the easiest way, well, I don't know if I even need or should say this, but I am going to say it. Students do better factoring if they don't have a minus sign here. And I don't know why, but they do. So the best thing to do would be to factor out the minus sign. If you did that, you would have x squared plus 2x, and then you would have minus 2 equals 0, and you have a minus sign down in front. Now that thing I quoted before, the x squared plus x minus 2 will factor into x plus 2, and x minus 1 is equal to 0. Well, the minus 1 isn't equal to 0, but if x plus 2 is equal to 0, x could be minus 2, or x could be 1. So we have solved for x then. So you see we're using some of our prerequisite knowledge. So what we're going to do is we're going to be integrating, and I'm going now to the bottom of this screen pretty much. Okay, and so the thing that's on top is the 2 minus x squared. The thing that's on the bottom is x in this case. So the area, and I'm down here, I'm in the last 3 lines on the right-hand panel. Yes?
We can't see the screen anymore, or at least I can't. Just FYI. I'm not sure if you
Okay, that's not good. So we need to go back. You can hear me though.
Yeah, I can hear you fine.
Okay, that's at least one thing. So I'm going to reshare, I think. So I'm sharing my application screen. And then go back to PowerPoint. And I'm here, and I'm going to hide that little thing.
Yeah, I can see it now.
Okay, so sometimes
Yeah.
you don't need to know this, but my uncle was a master electrician in the Navy. And sometimes when he was around, I would follow him along and we'd do electrical kinds of things. And the first thing he always did, even though he knew a lot, is he would unplug it, wait a minute, and plug it back in. He says, you always do that first, Jimmy. So anyway, so now you can see this. So now I think we're down here. I'm trying to point here. I'm hoping you can see my cursor. Okay, so this is A. The area then is going to be the integral from. Now we found the -1 and 1, or excuse me, the -2 and 1. We found that with all this algebra up here. And then the one that was on top, so we're going from -2 to 1. This is 2 minus x squared minus x dx. Okay, so I have to, and here there's actually not useful algebra to do. Sometimes there is, sometimes there's not. But we're just going to integrate this term by term. So if you integrate 2, that's 2x to the 0. So you add 1 to the exponent and divide by the new exponent. So that becomes 2x. And then you integrate minus x squared. You add 1 to the exponent and divide by the new exponent. That gives you this first term, which is the minus x cubed over 3. And then the last one is this minus x. That's minus x to the 1. So you add 1 to the exponent, divide by the new exponent. So it's minus x squared over 2. Now you got to plug in the numbers here. And by the way, plugging in the numbers here is actually a task, because you plug in 1 in here for all these. And again, you do have to do this arithmetic, and you do have to do this arithmetic without a calculator. So you should practice doing this on homework the same way that you're doing it in a game. Not a game, but in a high stakes assessment. But you put the 1 in, but then there's a minus sign, and that minus sign. And Dale, this goes back to the discussion you and I had during the, well, I don't know if it was during the break or during the first half of the second one, but is f of b, is capital F of b minus, that minus sign comes from there. But then you plug in -2. But you see, when you start plugging in -2 here, you've got algebra that you're doing, because here you're going to have minus. This is -2 cubed, but a minus times a minus is going to be a plus there. Here you got -2 squared, so that's just going to be minus, but then this is -2. So you really should check and make sure you understand these calculations. Now, this is arithmetic, but I will tell you that sometimes I encounter students who have been used to just using calculators to do things, and that's not how we do things at the College of DuPage. That's not how the math department at the College of DuPage decided to do this. So you're going to be doing this by hand, and you've got to get to the answer to get full credit on the problem. Anyway, if you do all that, you should get 9/2. Okay, so I'm going to pause here. I'm going to count to 10 Mississippi, just in case people have some questions and they're struggling to get their microphones working or something like that. So I'm counting to 10 Mississippi. But Nick, you can still hear me, right?
Yeah, you're good.
Okay, so I'm counting.
I have a question.
Go ahead.
So is it necessary to graph the functions before starting the problem, or do you not need to do that?
I would, you skip that step at your peril, and in fact, you're going to see that on some later problems that we do. Maybe you know that 2 minus x squared is on top and g of x equal x is on bottom, or maybe you don't. And so that's, I'm not going to I'm not going to say, oh, step A, graph the problem, although I'm telling you that's really the recommended thing is to sketch the graph so you really know what's going on. And what you're going to find out in later things is that the graphs aren't always obvious. Now, some students just say, oh, yeah, but I'll just guess on a problem like this, and then if the answer is negative, I'll switch the answer to positive. And that would work sometimes, but it won't work all the time. So anyway, that's my answer.
Okay, thank you.
So the recommendation would be for you to do it, but I'm also going to tell you something about me. I'm very much of a answer guy. And so if you get 9/2 for this answer, I will give you full credit. And some people say, well, do I have to write down the integral? I do integrals in my head. Well, that's good that you can do that. Okay, so oh, by the way, anytime someone asks a question, I start counting at the beginning again. So I'm counting again. Okay, I hit 10 Mississippi, so let's go on to the next thing. All right, so this is example 3. I'm going to read it to you. And again, in a real classroom, I'd ask the students to read this, but this isn't a real classroom. This is what it is. Okay, so the sine and cosine curves, and yes, we do trig in this class, intersect infinitely many times. Bounding regions of equal areas each time they intersect. And it says, as shown in the figure, I'm going to ask you, I would never say that. I would say, I wouldn't say as shown in the figure. I wouldn't graph this for you. You'd have to graph it yourself. But then the question is, find the area of one of these regions. Okay, so let's dive into to a solution. And by the way, I'm doing a little thing here. I'm just checking on what time it is. We're doing fine. Now, I think it shows up a little bit better the other way, so I'm going to go back to this version of it. So what you see here is the graph of f of x equals sine x. Now, the sine x is the dark colored curve. And again, it's periodic with a period 2 pi, as is the cosine. So it starts at 0 and it does this kind of thing, and you get back to we didn't go all the way. If I graphed it all the way, I would graph it to where it goes back to 0. But I didn't need to do that because it said, oh, this intersects many times, but all the areas are equal. So you just find the area of one of these. If I were asking this problem, I'd probably say, well, don't let me make that up. I'm just going to say that this is the area we're trying to find right here. Now, drawing slices is useful. So we draw this slice, and if I draw that slice to represent that rectangle, that tells me immediately that I am integrating dx. That is very valuable information, trust me. And when we do more complicated problems, perhaps tomorrow, that's going to be more and more important. So we have that. So what we can see is we need to know where this intersects. And so here is one point of intersection, and the other point of intersection is down here. But in both of those, the thing that's on top is the f of x, which is the sine x, and the g of x, which is the cosine. That is the light colored curve is there. Now, maybe, and this is going back to the question, I don't know who asked it, and it was a good question. Virtually every question is a good question. So let me just say that. But a student said, well, do you have to graph it? Well, I don't know. In this problem, you would have to know that, in that area of intersection, the sign is always on top. Now, maybe you know that, maybe you don't. And so graphing it is useful, but you're sketching the graph without a calculator. So if we're talking about things you want to review your trig a bit too. Okay, so we're trying to find this, we're integrating dx. So the next order of business, after we figured out that the sine of x was on top for that entire interval, is that we want to find the, points of intersection. Okay, so you see the points of intersection are when these two curves cross, and they cross when the sine of x, now I'm going over to the other panel now, the sine of x is equal to the cosine of x. Now there's all kinds of ways that you studied in your trig class to solve equations like this. What happens here in these notes is I say, okay, that means that I divide both sides by the cosine of x, because in that interval, the cosine of x is not equal to 0, so I can divide by it. And so this is sine of x over cosine x equal 1. We divided both sides by something non-zero, so that says we're in good shape. That means the tangent is equal to 1. Well, the tangent is equal to 1 twice between 0 and 2 pi. It's equal to 1 when you have pi over 4. And by the way, it's not 45 degrees because we do calculus with radians. So it's pi over 4, or it is 5 pi over 4. So you see there's two values. These are real numbers line. So you see this intersection here, this point is pi over 4. And this guy over here is 5 pi over 4. So we had to be able to solve a trig equation. So we have to be able to graph. We have to be able to solve a trig equation. And now we need to integrate. Okay, so the area is going to be equal to the definite integral from pi over 4 to 5 pi over 4. The guy that's on top is the sine of x. The guy that's on the bottom is the cosine of x dx. Now we have to use the fundamental theorem of calculus. Now the antiderivative of the sine of x is the negative of cosine of x. And the antiderivative of the cosine of x is the sine of x, and we have a minus sign in between. And this minus sign actually is from the fundamental theorem of calculus. I'm going to evaluate this at 5 pi over 4 and pi over 4. Now you're doing this without calculators, folks, and this is a 45, 45, 90 right triangle if you memorize things with your special triangles. So you plug these numbers in. First you plug in 5 pi over 4 to both things, then you put a minus sign, and then you subtract the whole of this evaluated at pi over 4. And you do the calculation, and what you get is 2 square root of 2. When you do that calculation. Okay, I guess I'm going to pause, count to 10 Mississippi in case there's some questions. Nick, we still good?
Yeah, you're good.
Great, thank you, Nick. Nick, you're helping me more than you actually know. This thing has been sometimes a nightmare, and you're making this not a nightmare, so that's good. Okay, so we'll move on to do, and you see it gets more and more complicated. So I'm just going to read what this chart says. To find the area of the region between curves that intersect at more than 2 points, first determine all points of intersection. Then check to see which curve is above each other in each interval determined by these points. So you see what happens is sometimes it changes which curve is on top, but the area between is that. Let's look at the picture of this problem. And here's the problem. I'll just state it. And by the way, I'm not telling you there's multiple points of intersection. You'll figure that out. But here, what we're doing is, in this example 4, we want to find the area of the region between the graphs of f of x equal, here's a cubic. It is 3x cubed minus x squared minus 10x, and g of x is equal to minus x squared plus 2x. So you need to sketch these. And going back to the discussion I had with one student, doing this in your head is pretty hard, or at least it could be. Let's look at the pictures of these. Now you're sketching the graph without, and by the way, let me give you a pro tip here, or a little bit of tradecraft. You see, I can look at this top guy up here at first, and you say, oh, there's a factor of x. That means x equals 0 is a root of this. So if I factor out the x equals 0, I have a quadratic that I can solve using the quadratic formula or factoring. So you see that's really valuable for this. And down here, we have g of x, and actually g of x also has a factor of x. So, you know, these things aren't impossible to do algebraically. But anyway, we're going to find the area between the graphs of these. So first thing is sketching a graph. So here we've sketched a graph. So let's see, the black one is f of x equal 3x cubed minus x squared minus 10x. So it looks like this. Now, you might say, oh my God, that would be hard to graph. Well, not really, because I know that 0 is a root, and I can figure out what the other two roots are by the quadratic formula if I want. And so I can figure out, you know, sketching the graph of that isn't too bad. And then this is a quadratic also that has 0 as a root. This one is the gray one here, and I get that. But now I want the area between the two. So the thing, a key thing to notice immediately from the graph is from -2 to 0, the f of x is on top, and from 0 to 2, g of x is on top. Now, I already told you how I figured out that 0 was a root, but figuring out the other roots will do now. But you see, it changes. So we're going to have to evaluate two integrals in order to finish this problem. We have to do this integral and this integral because we're really getting the sum of these two areas. Okay. So first thing is to sketch the graphs, and now you need to find where they intersect. So over here now I'm in the right-hand panel. I say begin by setting f of x and g of x equal to each other and solving for x. Okay, now here is the, let's see, this is the f of x and this is the g of x, so I set them equal to 0. And hot damn, something really nice happens. The nice thing that happens is this minus x squared cancels with that minus x squared. And then I move everything to the left of the equal sign, and I have 3x cubed minus 12x is equal to 0. And then I factor out a 3x, the common factor, and I get 3x times x minus 2 times x plus 2. See, you got to be able to do the algebra, setting that equals 0, and so you get minus 2, 0, and 2. Well, that tells you that this is minus 2 here. This is 0, and this is 2. Okay, so these are the points of intersection. And then I know from the graphs that I did that I'm going to have to do two integrals. The first integral is going to go from -2 to 0. And it's going to be the f of x minus g of x. So it's the area is the integral from -2 to 0 of f of x minus g of x. That is 3x squared minus 12x, and the, oh yeah, and actually, see, that's the difference between the two. You see up here, I really did that. I had 3x cubed minus x squared minus 10x. So when I move all this to the other side, I get this. That's the difference between the two. So that is 3x squared minus 12x dx. Plus, and then we have another integral because we change which one's on top. So this is the integral from 0 to 2 of, and now this is going to be g of x minus f of x. Now that would be the same thing as if we went up here, but we got everything on the other side. So this is going to be minus 3x cubed plus 12x dx, the integral from 0 to 2. Okay, so here I'm going to, the 3 just sits there. If I integrate x cubed, I add 1 to the exponent, divide by the new exponent, that is 3x to the 4th over 4, minus, here the 12 just sits there, but I add 1 to the exponent, so that makes x squared over 2, but then the 2 cancels into that, that makes it 6x squared. So I'm evaluating that at 0 and minus 2. And then I go to the other one. Now here, the minus 3 just sits there. This is going to then be minus 3. There's a minus there. It's hard to see. But that is minus 3x to the 4th over 4 plus, and this is going to be 6x squared, but now I'm evaluating at 2 and 0. So when I do this calculation, and you will be having to do this calculation, and you will lose points if you don't do this calculation correctly. So make sure that you do this calculation and do it correctly. You do all the calculation, and you get that the sum of these two is 24. Now I'm going to pause and count to 10 Mississippi, and I just checked the time. We're doing just fine. And Nick, you can hear me, yes?
Yeah, you're good.
Great, thanks, Nick. And Nick, I tell you, I hold my breath till I hear you say that. So that, I mean, I really do appreciate your help. Okay, so questions on this. I'll count to 10 Mississippi.
I have a question.
Okay, go ahead with your question, please.
So since you said it's a good idea to graph it out, how would you suggest graphing something like f of x out since it's a cubic?
Okay, well, all right. So first thing I would say is, and in fact, I think I'm going to go back to the previous slide here. I'm just looking at f of x. Okay, if I wanted to graph this, the first thing I would do is I would say, oh, there's a factor of x in there. That means x equals 0 is a root. Yes? I was waiting for you to do that, but maybe you didn't know. See, in class, it's so much better because you just make eye contact, and you know I'm waiting for you to say something. But anyway, x is a root, clearly. I know from this. So what I can do is I can factor the x out, and that means this is 3x squared minus x minus 10. That's a quadratic that factors. And so I can factor that quadratic easily, and I can have an idea of what the roots are. So you see I've broken the cubic down into a quadratic, and I can factor it that way. Here I also, well, this is maybe even easier, but down here x equals 0 is a root, so I can find out what those others are. Now, that got me to the point where I kind of could sketch these graphs and get an idea of what's going on with these graphs. But then I need to find the points of intersection, which is what I did over here. So that's my attempt to answer your question. And by the way, I always want to hear your questions. I always want to answer them. So if I ever don't answer your questions, follow up or something, because my intent was to answer your question. Okay, and anytime I get a question, I start my count over again. Okay, I hit 10 Mississippi, so that's good. Okay, we're going to go to the next problem then. Oh, it says, notice that in that example, if you didn't graph it, you just said, oh, I'm going to integrate from -2 to 2, and I guess that's always on top. You get a wrong answer. So the graph is important. And this just summarizes that you're doing everything we've done so far. We said the area is the area from the left endpoint to the right endpoint, the top curve minus the bottom curve. And that's if you had vertical rectangles when you draw them. But you can't have horizontal rectangles. And in that case, it's different. You're integrating dy, and this is the right curve minus the left curve. So we're going to be doing that in this next example. So this is called example 5. And I will just read it to you right now, and then we'll go through and we'll do this example. We want to find the area of the region bounded by the graphs of x equal 3 minus y squared. Now, by the way, you kind of, this is a little bit of a setup because you've solved for x, and then when this x is equal to y plus 1. But anyway, that's what we have. So first step again, you need to graph these, and you're graphing these without a calculator, because that's the way we do things at the College of DuPage. So we're graphing these without a calculator, and that's the first step. Then we're going to find the points of intersection. Then we're going to integrate. But here, we're going to be integrating dy. Now, you don't know that yet necessarily, but you will soon. So this is the problem. Okay, so you need to sketch this graph. Now, this time you sketch the graph and x equal y plus 1. This is the graph of that. So it's the black graph. And then you have what I'm going to call a gray graph, which is x is equal to 3 minus y squared. You might say, yeah, but you switched the x's and y's. Yeah, you did. Okay, so that's, I mean, I didn't do it, but that's what happens here. So we have this. Now, I'm going to stress something. This is an important point, everybody. If you tried to do this without drawing the rectangle horizontally, you would change the graph that's on top. So if I were trying to do a dx going through here, I would go from the x is minus 1 all the way to this point. And there, the x function, this line is on top. But then going from here onward to this point, dx, that would be hard to find. And it would be a separate integral because the top function over here is the parabola, and the bottom function over here is the parabola again. Up here it is plus the parabola, down here it is minus the parabola. So once you've drawn the picture, it is clear, and you've drawn the slice, it is clear that you would really like to do this using the dy, because you see in this picture, the function that always has the greater value is the parabola. So the parabola is always going to be on top, and the line is always going to be on bottom between these two. And we understand that, I'm going to say only from the graph, but drawing the slice here makes it an easier problem. You can do it the other way, and you should get the same answer, but drawing the slice is a very important step. Okay, so we're drawing the slice, and when I draw a horizontal slice, that tells me that that is the delta y, and that means this is dy. And by the way, folks, if this thing over here is dy, damn it, hold on. If this thing over here is dy, I press the damn mouse button. Okay, if this thing is dy, these things better be y's if you're integrating them. Okay, so the one that's bigger is 3 minus y squared. So this is 3 minus y squared is on top. The one that's, it's not on top, but it's further right. This one is to the left. And notice, everybody, that we're taking the bigger one minus the whole of the smaller one. Those parentheses are damned important. You will get the wrong answer if you do not use those parentheses. Okay, so now what you're going to do is you're going to do algebra. And so you do algebra again. So this is 3 minus y squared. This is minus y. And 3 minus 1 is 2. And there's the minus y. If you do all the algebra, you get this. Now, you do have to solve for where these two things intersect. And I guess I didn't show you that here, but it's not hard. You say, when does y plus 1 equal 3 minus y squared? You can solve that. And you end up with it as minus 2 and 1. So we integrate each one of these. So this is going to be add 1 to the exponent, divide by the new exponent, y cubed over 3, minus this is y squared over 2. This is 2y. I plug in things. You have to be careful about these things. But when I plug in the numbers, this minus sign here is from the fundamental theorem of calculus. You do all the calculation and you get 9 over 2. Now, a serious student probably, when they're reviewing the notes and things like that, would actually try to do these problems again, maybe themselves more slowly, because that would be good practice. Okay, so we're in good shape, and let's see. I'm going to Nick, you can still hear me, right?
Nope, not at all.
I'm hoping you're joking, but good for you.
I'm joking.
A sense of humor will serve you well in life, so that is good. Okay, I'm going to count to 10 Mississippi in case there's some questions on this problem. But the big thing is it makes a difference which way you draw the slice. And that's going to be a big thing when we meet tomorrow.
So, Professor, when do you know which direction to draw the rectangle?
After you've drawn the curve, the curves, and you see what's the easiest one. And by the way, when I say this, I'm not being mean. I'm going to repeat what I tried to say before. But you see, okay, we drew the picture and pretend that slice wasn't there. Okay. Then what I'm going to do is I'm going to say, well, I don't know if it's dx or dy, so I'll draw a dx slice. So if I draw this slice, but look what happens when I know the picture, if this is a vertical slice. Well, from here to here, the black curve is on top. But then it changes from beyond this point where x equal 2. The parabola is on top, the plus part of the parabola, and the minus part of the parabola is on the bottom. You can still do it, but you're evaluating two integrals. That is harder. But you say, oh, but let me look at the picture. What happens if I draw the horizontal slice, meaning it is delta y, meaning I'm integrating y. And when I look at the picture, I can say, oh, the same function always has higher values than the other function. So that's the better way to do this problem. So it comes from drawing the problem and, of course, thinking. Okay.
Thank you.
I hope that helped. My intent always is to answer your questions. Okay. Oh, and here they're doing it again. And by the way, this one did it the other way. They drew the horizontal slice. Maybe I should have done this one quicker, but here they're drawing these. But look what happens, guys. And I'm just going to do it over here. But now that when you draw that, you've got that. Now, if you're doing dx, everybody, these things here have to be functions of x. So you see what happens then is these are now functions of x. I'm doing dx. So I go from x equal -1 to x equal 2. But now I had to solve this. I had to rearrange this because I needed this not to be x equal y plus 1. This has to be y is equal to x minus 1 because that has to be a function of x. And from here, from 2 to the next point, and by the way, you'd have to know that this point is 3, and that actually is very obvious from the graph. When y is equal to 0, this is equal to 3. So you see that x is 3. So then we go from 2 to 3. But you see, this is the top function is the positive part of, and I solve for y. This is plus the square root of 3 minus x, and this is minus the square root of x. Now, think about that, folks. When you take the top guy minus the bottom guy, the minus in the bottom guy has a minus in it already. So that is a minus. A minus is a plus. Whoa. So you have things you need to integrate here. And here you need to do, well, you don't have to use this, but you're probably doing a u substitution. You're letting u equal 3 minus x. So you, I'm trying to look and see if this is, yeah. So when you integrate these term by term, you're going to get x squared over 2 minus x. But here it's going to be, you add 1 to the exponent, divide by the new exponent. So that's a 3/2 in the denominator, which is a 2/3. And you're plugging in numbers. So you see there is quite a bit of arithmetic involved in this problem, and you're evaluating two integrals. That's why the first way to do this was probably a superior way. But notice that you do get the same answer. And in fact, I have asked questions on tests and things like that where I said, hey, do it both ways. Okay, so that is possible that you have that. Okay, so you could do it the other way. And here is a question. And if we were in a class, I'd probably ask everybody to do this. I'm asking everybody to do this right now. And this is a little bit of a test. Okay, now it's not a test like you're getting a grade, but it is a test. And everybody, I'm encouraging you, really write down answers to this to see if you got it right. On the left-hand side, are you going to do dx or dy? On the right-hand side, are you going to do dx or dy? And I mean, it's not a test. So over here, you see, you really want to do horizontal rectangles, which means dy is an easier way to do this problem. And here's, by the way, what that problem is before you graphed it. But over here, the thing to do that would be better is to do dx. So this would be dy, this would be dx, and establishing, proficiency in doing this is a good thing. Okay. All right, so now I'm going to talk about this, and this is called integration as an accumulation process, and this also will sometimes happen. So what we do often is we take a known pre-calculus formula to find a representative element, and then we get a new integration formula. And this was what we really did, because we said already the area of the height times the width is a rectangle, and that tells us that we're going to be looking at this delta x, which we integrate this. Now we will do this later on with more complicated formulas, and in fact that's going to happen, wow, next period. Okay, and here they're just really saying that you're adding up area. So as you're going along, see, you're adding each of these rectangles. So you start. So if you don't go anywhere from -2, it's -2 to -2. That integral is 0. But then if you go up to -1, you get this part of the area. If you go up to 0, you get this part of the area. If you go up to 1, you get this part of the area. And if you go all the way, you would get 32/3. So you can think, and it is often useful to think of integration as accumulation of areas. And more about that next time. Now, one of the things I have to do is I have to watch the clock for you, and I have watched the clock for you, and we're nearing the dismissal time. So I'm just going to say a few things. And after I say maybe a few things, I'll pause and see if there's any questions that people have. But we did a good job of covering section 5.6 in the textbook of reference. We did a good job of that. The examples that I did were not from your textbook. So those of you who have that textbook, I would encourage you to read that textbook, because those are different examples than the ones I did. They're very similar, but still they are different. So you see there's something for you to do. I also gave you a bunch of homework problems that are recommended to do, and we'll start next period with an unquiz. And again, that's just checking to see how is your mastery level, and that'll be starting at 8 o'clock. So that's what will be happening then. So now I got like a minute left for questions or so, but I'm just going to throw it open for any questions. And this is going to be whoever jumps in for. And Nick, thank you so much, by the way. And I will try to find another victim next time. Okay, so questions. Someone raised their hand. I don't know what that means. So maybe they just raised their hand. Oh, here. Hold on. I think he chatted, but I have to change the channel to chat. Okay, so I'll try to figure it out. How much will the quiz be worth? Sorry if this was answered before. Yes, it is, but I'm happy to answer it before. It is an unquiz. It is all the value of having a quiz and figuring out if you know what you're doing or not. But no one is penalized for doing poorly.
Hello?
So it is an unquiz. No, there is no extra credit. The extra credit, I've had students who say, hey, I will write you a book report about a great mathematician. I teach math history. I know more about math history than most people do. I don't need that person to buy something off the internet and turn it in. What you want to do is, okay, the question is, this is the last question I'm answering in class. Our quizzes during lecture time. The unquizzes are during lecture time. And are there any other assignments that we need to complete to go forward towards our grade? Yes, watch the videos, watch this video, because all of that was answered multiple times in that. And I'm not being rude, I'm just saying, why don't you do that? Because that will answer your questions, okay? Okay, so that's it. I'm turning off the recording, stop recording.